Alright students, today we're going to complete the forces foldable that you have. Now this has to be folded a certain way, so make sure you pay attention to how I fold it. Alright, first thing you have to do is make sure the side that you can see is the side that says 6, 7, 8, 9, 10, and 11, just like I have here. Alright, that's the side that's visible to us. We're going to take the top part and we're going to fold it down all the way across so that what we see is forces. After you take that and fold it across, you're going to fold the left side over, and then you're going to fold the right side. Alright, and so this is how your foldable should look when you're finished. Again, I'll start that over, open it all the way up. All you're doing is you're folding the top straight across. And you're going to fold the left side over. Make sure you put that crease. And fold the right side over. Now I recommend, this is going to be glued in your interactive notebook on page 21. But I'd recommend that you take down your notes on it first and then glue it in. That way you have no problems. Alright, so the first thing we're going to look at, and this is going along with the PowerPoint that I put on the on your classroom.google.com. So all of you should get on your Chromebooks and access that now, so you can follow along as we fill out this foldable. Alright, the foldable that we're doing is forces. It's over motion and forces. So the first thing it asks us to do is define what a force is. And a force can be defined as a push or a pull. So we'll go ahead and write that in. A force is a push or pull. So that tells us forces are going around every day. When you're shaking somebody's hand, every step that you're taking, you're applying a force, a push or a pull. That foot goes down, it's pushing. When you're pulling it back up, you're pulling. The next thing it asks us to do, number 2, is compare the strength in direction of forces using arrows. Alright, Coach Smith is back. I decided to go ahead and just pull up the PowerPoint so you can follow along with me as you look at this, because I thought about it. Obviously, if you're following along with me watching this video, you're not going to be able to access the PowerPoint at the same time. So we'll just go with it together. As you can see, the image here on the PowerPoint shows something moving across the screen that says pull you, push me. And if you notice, when it's pulling, it's actually looking like it's being pulled across the screen. This is showing you what a force is. Like I said earlier, a push or a pull. And the next side says forces can be objects. Forces can affect objects. If an object is at rest, a force can move the object. How can a force move it? Well, we just said a force is a push or a pull. So obviously, if you have a chair sitting somewhere, that's an object at rest. If we come through and we push it, we can move it to a different direction. Or if we pull it, we can move it toward us. If an object is moving, a force can change the speed of an object. Think about it. And it's a different way of thinking. But if you're in a car and you're already going a certain speed, if you apply more force to that gas pedal, which in turn is supplying more gas to the motor or the engine, what's happening? That car is going to speed up. Same thing with a toy car. If you're pushing a toy car across your kitchen floor, little brother, little sister's pushing a toy car across the floor at one speed, if they apply more force to it, push it a little bit harder, then it's going to speed up. When you're talking about sports, think about a soccer ball. You kick that soccer ball at a certain speed, and whether you want to slow it down or speed it up, then, or make it go faster rather, then you'd apply a different type of force. You would obviously push it harder if you're trying to speed it up, and you're going to pull it towards you basically to slow it down. You can also, thinking about that, change the direction that it's moving. Think about when you're dribbling a basketball. If you want it to go another way, you'll simply change the direction. You apply force in a different direction to change the direction that it's going. Football, if you just want to toss it straight up in the air, you can, or you can throw it forward. So our forces not only change the speed, but they also change the direction of objects as well. And here's an image of a truck coming through. Of course, that truck is going to move that car because it has more force. Why does it have more force? Well, it has more speed, and it also has more mass than that car is traveling. So it's going to do some damage to that car. Also, if you look at the top of that truck, what happens to the ladder on the top? Well, when the truck applied force to the car, that car also applied a force to that truck. It wasn't as strong as the truck, but it was enough to over time help it come to a stop. Well, that ladder on top wasn't secure. So since that ladder wasn't secure, it was going the same speed as the truck, but when that truck came to a stop, that ladder continued to go that speed, and so it flew off. So number 2 said compare the strength and direction of forces using arrows. We'll come back to that one in the end because I want to add some numbers to that one to help with that one. Number 3 says draw forces, same direction and opposite direction. Alright, I'll show you what they mean by that in just a second. Forces can affect objects. A force can also affect an object without making it move. Like when you sit on the inner tube and the sides bulge. Tells you to think about that for a few minutes. You've applied a force to it. It didn't move technically any amount of feet or inches. All that happened was that since you applied your force and the air is already in that tube, it just made it kind of bulge out or stick out. Is another is a synonym for the word bulge. And there's old Minnie chilling on that inner tube. Alright, your strength and direction of force. The head of an arrow tells you the direction. So, since this arrow is pointing to the right, that means that that force is moving to the right. That particular force. And the width of an arrow, which means the wider an arrow is, tells you it has more strength. So a thin arrow doesn't have as much strength as this wide arrow here. This is the part I want you to copy down, where it says compare the strength and direction of forces using arrows. You're going to draw 2 arrows. You're going to draw a big arrow, and you're going to draw a little arrow. These 2 here. And for that big one, you're going to put more force and then for the small one under it, you're gonna write has less force. So I'll do that, and then I'll show you what it looks like in your interactive notebook. Alright, so I've drawn my two arrows. As you can see, my handwriting is horrible. This is one arrow here. It says it has more force, and then the smaller one says it has less force. Alright, and then since both of them are pointing to the right, that means the force on both of these is going to that right side. Alright, if you look at this red arrow here in the corner that's kind of hiding, you'll see that that arrow there has less strength or force in the direction it's going down. So force can move downward. Think about it every day you walk. When that foot presses against the ground, then you're pushing a force downward. Right here, we're just showing an interpretation of the forces. It says forces are shown in pairs. Forces in the same direction look like this. Alright, so these two would be working together. If you want to get a visual of it, you could pretend that there's a chair right in between these two arrows. This person in front is pulling that chair, or big desk, whatever you want to think of, is pulling, and the person behind is pushing. So they're working together to push it and pull it in that same direction. Alright, how do we know it's two different forces? Well, even though they look about the same size, they're also two different colors. So that would also tell us and give a good indication that they're probably two different colors. So on your paper, you're going to draw these two arrows going in the same direction. Now, you may not have a red and a blue. If you do, that's fine. Go ahead and color that in. If you don't, what I recommend is that you just simply shade one end and leave the other white on the inside. Alright, so I'm going to take a couple of minutes and draw that and show you what it looks like. Alright, so here you go. Two same forces working together here in the same direction. One is pulling, one is pushing. But their forces are being applied in the same direction there. Forces in opposite directions look like this. Alright, so they gave you two different ones. Two different ways to look at it. This first one here, you can look at it kind of like tug of war. They have a rope. This group of people here is pulling to the right. This group of people is pulling to the left. Now the arrows look like they're about the same size, so that means the forces are balanced. So that rope isn't going to move because they have equal amount of strength. Alright, so that's a balance.